Yeah, good afternoon, children. So, as you know that already, we have started with the magnetic effect of electric current. In that chapter, we have studied about magnetic field, magnetic lines of forces, how different type of magnetic field lines, how they are produced in circular coil, straight conductor, solenoid. And in previous class, we have studied about the principle of motor, working of motor, construction of motor. In this chapter, in this part of the lesson, or in this video, we are going to study about the electric generator. What is the principle involved in the working of electric generator? Before that, before knowing about generator, we should know about something called as EMI, electromagnetic induction. Electromagnetic induction. So first we'll learn about the electromagnetic induction. EMI. So remember this EMI. You can remember the electromagnetic induction. Understood? So already you know that at the beginning of this chapter, we have learnt about how the magnetism is produced by electricity. You know the basic principle of producing a magnetic field by electricity. Hans Christian Ørsted is a scientist who discovered that whenever a current is flowing in a conductor, it produces a magnetic field. It produces a magnetic field. That we have learnt already. We know how to produce a magnetic field by using electricity. Understood? But later on, another scientist named as a renowned scientist named as Michael Faraday. The contribution of Michael Faraday to the science and technologies contribution is too high, if it tell. So he proposed the two law of electromagnetic induction and two law on electrolysis. Michael Faraday law of electrolysis and Michael Faraday law of electromagnetic induction. So in this chapter, they have gone about the electromagnetic induction. Understood? So you know that already. Ørsted told that a current carrying conductor can produce a magnetic field. Similarly, Michael Faraday thought, so if electricity can produce magnetic field, why not the magnetic field can produce an electricity? He thought like that, and he succeeded, and he proved that the magnetism can produce electricity by a simple demonstration. Understood? So that is only called as law of electromagnetic induction. Understood? So he proposed the law. And what do you mean by electromagnetic induction? Means what you can tell, whenever a magnetic field linked with a conductor changes and induced current is produced, or you call it as EMF, electromotive force, electromotive force, electromotive force. EMF or induced current is produced. Means what? Whenever a magnetic field linked with a conductor, changes, whenever a magnetic field changes which is linked with a conductor, then induced current will be produced. Understood? So that he demonstrated by simple experiments. He taken a hollow cardboard tube. He took a insulated copper wire and wounded on this tube, on this tube. Is it clear? So this is a hollow tube, and on that he wounded a insulated copper wire, and the free end of the wire is connected to the device called galvanometer, which contains needle. Galvanometer. It is a device used to know the production of induced current. That device is connected. So this device is connected to the free end of the wire, copper wire. So in case of Oersted experiment, in this here the source battery was there. In case of Oersted experiment, in case here there was a battery which was electricity was sending here, and magnetism was created. But in this case, what happens? In place of battery, we have placed the galvanometer to show the production of induced current. Understood? So then he taken a bar magnet. For this demonstration, he has taken a bar magnet. Understood? Bar magnet. So you know that already. A magnetic field is produced in a bar magnet. So the bar magnet, you know that magnetic field is produced. So now we'll come back to the law. Law states that whenever a magnetic field linked with a conductor changes. So this is a magnetic field, this is the conductor, this is the conductor, and this is the magnetic field. So the magnetic field is linking with the conductor now. So this magnet is pushed inside the coil. When it is pushed inside the coil, the needle of the galvanometer shows deflection. It shows deflection. It was straight. It shows deflection now. Deflection. When it is pushed, see, when it is pushed, what happens actually? The magnetic field linked with a conductor. Magnetic field linked with a conductor changes. Means when you push it, electricity is produced and the galvanometer shows the deflection. Understood? If you keep stationary, if you keep this magnet over here, if you keep this magnet over here constant without moving, then no electricity is produced. No electricity is produced. Remember. So this is the definition. You can see this definition. Whenever a magnetic field linked with a conductor changes here, changes. There should be change in the magnetic field. There should be change in the magnetic field linked with the conductor. Then only the electricity is produced. Electricity is produced, or induced current will be produced, or electromotive force will be produced. So this is the first law of electromagnetic induction and definition of electromagnetic induction. Electromagnetic induction means what? It is nothing but the magnetic field linked with the conductor. When the magnetic field linked with the conductor changes, an EMF is produced. So we are introducing this magnet inside this coil. So deflection shows we are removing. Removing also shows deflection shows this side. It moves like this. Understood? So if this magnet is stationary inside the coil, there is no generation of electricity. Or it is not that. See, you keep now you keep this as constant, static. Don't move this. Now we will take this. See, now what I told, this was fixed, and we are moving the magnet, and the EMF is produced. We will do now. This magnet will keep it constant. This magnet will keep it constant, and we will move this. We'll move this. We'll keep this magnet constant, and we will move this to here like this. Then also EMF is produced because there is a change in magnetic field now also. If you move this around this magnetic EMF is produced, or if you move this magnet also EMF is produced. So we need the change here. The magnetic field linked with the conductor changes. When this magnetic field is linked with the conductor changes. So when it is moves inside and outside, then it produces. See, second law what states, one more law is the electromagnetic induction. It states that the magnitude of the electric current, the magnitude of the induced current. See here, the magnitude of the induced current is directly proportional to the relative motion between the coil and the magnetic field. Means the relative motion between the coil and the magnetic field will produce more current. Means the quantity of the current produced in a coil depends on the rate of change of magnetic field linked with the conductor. Means you have to continuously, the magnet has to push inside and taken out, push inside and taken out, push inside and taken out. On that basis, how much speed you are doing that, on that basis the magnitude of the current depends. Magnitude of the current depends. Is it clear? This is about the electromagnetic induction. Electromagnetic induction. See here, if magnet is stationary, EMF is not produced. Induced current is not produced. Magnet is pushed inside coil. EMF is produced. Or induced current is produced. Understood? Magnet is removed outside. Induced current is produced. Induced current is produced. Induced current is produced. Understood? The magnitude of induced current depends upon relative motion between coil and magnet. Coil and the magnet. That it depends. It depends on that. Let's look. If the so means if the relative motion between the coil and the magnet is more EMF is produced. More EMF is produced. Understood? So more EMF is produced. Similarly, number of turnings of conductor copper wire is more EMF is produced. EMF is produced. More EMF is produced. Means the coiling here. The number of coiling is more means more EMF is produced in the coil. So this is how the EMF is produced. So number of turnings in the coil. And the magnitude of the electric current depends on the power of the magnet. More powerful magnets are used, more EMF is produced. Understand? I hope you understood this concept. So this is how the electricity is produced by using magnetism. Understood? In case of this, if you place in case of galvanometer, if you place a bulb, what would have happened? The bulb would have glowed. The bulb will glow when there is a relative motion between the coil and the conductor. So on this principle only the electric generator works. So in the page number 127, they have given about electromagnetic induction, and in page number 128, they have given about their demonstration of Michael Faraday. They have given about the Michael Faraday also here. So Michael Faraday was an experimental physicist. He had no formal education. See, was not having any formal education. Means that's why we tell experience makes man perfect. So experience is a good teacher. So many of the scientists, they were not having a formal education, but they have proved, they have contributed lot to the human society. Say similarly, he also electromagnetic induction, law of electromagnetic induction, and also he proposed the law of electrolysis. See here in page number 128, they are given the demonstration of Michael Faraday. This was the demonstration done by Michael Faraday. Here there is a tube and the wire is coiled and galvanometer is connected here and the magnet is here and it is pushed inside the coil. Understood? So this is about the electromagnetic induction. So electromagnetic induction is a principle of working of the electric generator. So what is electric generator? You know that motor. So electric generator. So it is a device which converts mechanical energy into electrical energy. So what is generator? Say, name only sir, generator. It is generating something. What is it? What is it generating? It is generating electric current. That is only electric generator. By using electricity, so by electric generator means what? By using the magnetic field, we are generating electric current. How? By mechanical energy. By mechanical energy means inside the motor. So we'll go back now to the motor. Motor is a device which converts electricity into mechanical energy. We switch on the fan, and fan will start rotating. Means the electric energy is converted to mechanical energy, that is rotational mechanical energy. Here we are doing in a reverse way. In the generator, so we are providing mechanical energy. Hand dynamo is there. Hand dynamo is there. We will rotate the shaft. We will rotate the armature by our hand, and there is a change in the magnetic field inside the generator. That's why electric energy is converted. Mechanical energy. We are rotating the shaft of the motor. Generator we are rotating, and electricity is produced. See, in the cycles, dynamo are fit. In the old cycle, if you tell, the old cycle dynamo are fitted actually. So when we pedal the cycle, so the cycle starts moving. During that time, the dynamo was connected to the tire, and the dynamo was inside the dynamo. The coil was moving. Because of that, electricity was generated. See, one more example I can give. See, in the companies and all we have generators. So in our school we have generator. When there is no current, we will on the generator. Generator, what it will do? It works on diesel. So we will put the diesel and will allow the generator to work. Generator produce electricity for us. So hydropower station. The moving water is allowed to fall on the turbine of motor. The turbines are connected to the motor. So when turbine rotates, there is a change of magnetic field inside the generator. So electricity is produced. Electricity is produced. On that basis, this on basis of electromagnetic induction, this electric generator works. Means the electric generator works on the principle of electromagnetic induction. Understood? So this is about the electromagnetic induction. So in the next class, we'll see the working of the electric generator. Is it clear? So this is the principle involved, and there is a rule to understand the working of electric generator, that is Fleming's right-hand rule. So Fleming's left-hand rule is for motor, right-hand rule is for the generator. Is it clear? So I hope you have understood the concept of EMI, that is electromagnetic induction. In the next class, we'll see the working of the electric generator. Okay. So I hope you understood the concept. So if you understood the concept, please raise your hands so that we'll stop the class for today. Okay. Okay, thank you, Sriharsha, Ashwit, Yashaswini, Shaman, Parnav, Pratambat. All are raising the hands. So read the textbook. And try to Somabhat, thank you, Vaishnavi, thank you. Okay. So please read the textbook and try to understand the concept and correlate the concept with what I thought. Understood? If you come across any new word or new technical word, please contact me so that I can help you out. So if you have any doubt, please ask me. So you are going to write the 10th board exam. So please read the textbook thoroughly. The textbook is a Bible for you. Complete the textbook and go for the other books, other reference book. Please read the textbook thoroughly so that you can answer any type of questions and you can understand the concept much better. How does the compass work? Say compass works on the basis. The Earth acts as a magnet. Remember that Earth as a whole acts as a magnet. I told you while telling the magnetic field concept. Whole Earth act as a magnet. So you know that opposite poles attract each other. Similarly, the north, on that basis it will show the north and south. Needle will show north and south actually. Okay. So this is how the generator works on EMF. That we'll see it later. Understood? I was telling about the exam. So please read the textbook thoroughly so that you can answer the questions very easily. Say, don't run behind the marks, I'm telling you. Don't run behind the knowledge so that marks will follow you. Don't run behind the marks, leaving the knowledge behind. You get the knowledge, the marks will follow you. Okay. Thank you very much. Have a nice day.